Hello and welcome to Conspiracy Chronicles, your source for deep dives into the world of intriguing conspiracy theories. I'm your host, Gorkum Yuxel, and today we're peeling back the layers of the infamous Flat Earth theory. The Flat Earth model proposes that Earth is not a spherical planet, but rather a flat, disc-like structure. In this model, the North Pole is at the center of the disk, and the edges are encircled by a massive ice wall that holds oceans in place. So what does that exactly mean? Think of it like a pizza. The crust is this big ice wall that encircles the entire thing, and everything else is the toppings. So the North Pole is right at the center, and all of the continents and countries are like the pepperoni that's on top of the entire pizza. So according to the Flat Earth model, the sun and the moon move in a circular path around the disk. It's casting light and creating day and night cycles. Their paths are believed to vary in altitude, explaining seasonal changes and eclipses. Flat Earthers often reject the concept of gravity as it's understood in the spherical Earth model. Instead, they propose that objects fall due to upward acceleration. It's a concept known as universal acceleration. This is meant to explain the sensation of gravity. The Flat Earth model contradicts extensive scientific evidence, including observations of ships disappearing over the horizon, the way celestial bodies move, and the behavior of light and satellite imagery that clearly shows a spherical Earth. Alright, to start, let's explore the origins of the Flat Earth concept. It might surprise you that the idea of Flat Earth was largely debunked centuries ago. The ancient Greeks were some of the first to suggest the Earth was round, and their findings were later confirmed by explorers like Magellan. However, the Flat Earth theory has experienced a resurgence in modern times. Let's transport ourselves back to ancient times when the concept of a flat Earth was prevalent. We'll explore how the Greeks and other civilizations shaped our understanding of the Earth, and how these notions evolved over the centuries. Ancient civilizations such as the Mesopotamians and Egyptians initially believed in a flat Earth. However, it was the Greeks who introduced the notion of a spherical Earth. Thinkers like Pythagoras and Parmenides proposed that the Earth's shadow on the moon during a lunar eclipse was circular, indicating a spherical shape. Now enter Aristotle, one of history's greatest philosophers. He put forward compelling arguments for a spherical Earth by observing the shape of the Earth's shadow during lunar eclipses. He also noticed that as ships sailed away, their hulls disappeared first, followed by the rest of the ship, evidence of the Earth's curvature. Eratosthenes, a mathematician and astronomer, made a monumental contribution to our understanding of Earth's shape. By measuring the angle of the sun's rays in two distinct locations and calculating the distance between them, he estimated Earth's circumference with remarkable accuracy. The fall of the Roman Empire led to the decline in scientific inquiry, and during the Middle Ages, some societies reverted to flat Earth beliefs. The spread of Christianity and literal interpretation of religious texts played a role in this regression. The Renaissance, however, marked a turning point in intellectual history. Pioneering thinkers like Copernicus and Galileo reintroduced the idea of a spherical Earth supported by astronomical observations and mathematical reasoning. These ideas set the stage for the modern understanding of Earth's shape. And there you have it, a journey through time that reveals how Greeks and subsequent civilizations shaped our understanding of the Earth. From the initial flat Earth beliefs to the pivotal contributions of Aristotle and the Renaissance thinkers, our perception of the world beneath our feet has come a long way. So now that we have a short and quick understanding of the history of the flat Earth theory and how it evolved into a round Earth theory, let's jump into the modern flat Earth movement. The modern flat earth movement gained momentum in the 19th century and has continued to capture the attention of a small but dedicated group of believers. These individuals claim that evidence supporting a round earth is fabricated by governments and organizations as part of a grand conspiracy to control information. His book, Zetetic Astronomy, Earth Not a Globe, challenged the established scientific consensus and became a cornerstone of the movement. As the 19th century progressed, advancements in technology and communication enabled like-minded individuals to connect and share their beliefs more easily. This allowed the flat earth theory to spread beyond borders and attract followers from various corners of the globe. The dawn of the internet in the late 20th century provided a platform for the flat earth movement to flourish. Online communities, forums, and social media became spaces where flat earthers could gather, share ideas, and engage in discussions. This virtual connectivity played a significant role in expanding the movement's reach. Throughout the 21st century, several celebrities and public figures embraced the flat earth theory, adding a layer of legitimacy to the movement in the eyes of some. Their endorsements brought the theory to a broader audience and ignited conversations about the nature of belief, science, and media influence. From musicians to athletes, celebrities have periodically endorsed unconventional beliefs, and the flat earth theory is no exception. Take, for example, rapper B.O.B. and retired basketball player Kyrie Irving are the two notable examples who publicly expressed their belief in a flat earth, sparking discussions in mainstream media. The rise of social media platforms like Twitter, Instagram, and YouTube has allowed celebrities to share their beliefs directly with fans. This instant connection between influencers and their audiences can amplify unconventional ideas, even when they contradict established scientific knowledge. Mark Sargent is perhaps one of the most well-known and outspoken proponents of the modern flat earth theory. He gained prominence through his YouTube series, Flat Earth Clues, where he presents arguments and evidence supporting the idea of a flat earth. Before embracing the flat earth theory, Sargent worked in the video game industry. His journey into the movement began in 2014 when he stumbled upon an online flat earth discussion. Intrigued by what he had encountered, he embarked on a personal quest to explore this unconventional belief. Sargent's YouTube series, Flat Earth Clues, became a focal point for spreading his perspective on the topic. The series examines various aspects of the flat earth theory and encourages viewers to question the accepted narrative. Sargent's engaging presentation style and his ability to articulate complex ideas have attracted a sizable following. In addition to his online presence, Mark Sargent has participated in flat earth conferences and events. His public speaking engagements have provided a platform for him to share his views with fellow flat earthers and curious attendees. Sargent challenges mainstream scientific explanations related to the Earth's curvature, gravity, and the behavior of water. His arguments often center around visual observations and the reinterpretation of established scientific concepts. Mark Sargent's influence extends beyond his online presence. He has played a role in fostering a sense of community among flat earthers, encouraging them to share ideas, engage in debates, and explore alternative explanations for the world around them. While Sargent has a dedicated following, he also faces criticism from the scientific community and skeptics who challenge his claims. Critics argue that his arguments often overlook or misrepresent scientific evidence that supports a spherical Earth. It's evident that Mark Sargent has played a significant role in popularizing the flat Earth theory through his online presence, public speaking engagements, and engaging with the flat Earth community. His impact raises important questions about the role of individuals in shaping alternative belief systems in the digital age. So, what exactly are the flat earthers actually claiming here? How much fact versus fiction is there to their claims? Let's take a second to dissect them one by one. Claim number 1, lack of visible curvature. Well, one common claim made by the flat earthers is that the Earth appears flat and devoid of curvature in our everyday experiences. However, scientists have explained that the Earth is so large that the curvature isn't readily perceptible at small scales. The lack of visible curvature argument asserts that the Earth appears flat in everyday observations, and therefore it must be flat. This claim challenges the widely accepted understanding of Earth's curvature. The sheer size of our planet is a crucial factor to consider. Earth's diameter spans thousands of kilometers, about 12,742 kilometers to be exact, or that's 7,918 miles. So its curvature is indeed subtle over short distances. The horizon may appear flat to the naked eye due to the vast expanse of the planet. When we ascend to higher altitudes, whether by climbing a mountain or flying in an airplane, we gain a broader view of the landscape. At these heights, the curvature of the Earth becomes more evident, and you can observe the horizon gradually curving away. The perception of a flat horizon is partly due to the limitations of human vision and perspective. Distant objects seem to converge at the horizon, creating the illusion of a flat plane. This is a visual effect, not an accurate representation of Earth's actual shape. Photography can also play tricks on our perception. Wide-angle lenses can introduce distortions that make the horizon appear flatter than it actually is. It's essential to consider the equipment used and the specific conditions when analyzing images. The scientific consensus is clear. Earth is a spheroid. While the lack of visible curvature argument may resonate with some, it overlooks the cumulative evidence from various sources, including satellite imagery, astronomical observations, and circumnavigation routes. The lack of visible curvature argument is more fiction than fact. The subtlety of Earth's curvature combined with our limited perspective and influences of visual effects can create the illusion of a flat horizon. However, when we examine the totality of scientific evidence, it becomes evident that Earth's shape is indeed spherical. Claim number 2. Flight paths and the horizon. Another of the arguments presented by flat earthers is the notion that flight paths on a globe Earth would be different from what we observe. They suggest that if the Earth were curved, airplanes would need to constantly adjust their trajectory to account for the curvature. Flat earthers often question why the horizon appears level and doesn't seem to curve away as they believe it should on a globe Earth. They claim that if the Earth were spherical, the horizon should drop as you ascend in altitude. In response to the flight path argument, the scientific explanation considers the immense size of the Earth. When flying long distances, planes follow a curved path known as the Great Circle Route, which is the shortest distance between 2 points on a sphere. The behavior of the horizon is influenced by Earth's curvature. As you ascend in altitude, the visible portion of the Earth becomes more extensive, leading to the appearance of a dropping horizon. This phenomenon is gradual due to the vastness of the planet. Perception of a level horizon arises from the Earth's enormous size relative to our perspective. Over short distances, the curvature is virtually imperceptible. But over extended distances or at greater altitudes, the curvature becomes more pronounced. To truly appreciate the Earth's curvature, one needs to witness it from higher altitudes. The visual evidence from high-altitude balloon flights and astronaut observations provides a first-hand glimpse of the planet's spherical shape. When all is said and done, the flight paths and horizon behavior align with the globe model. The scientific explanations consider Earth's size, the curvature, and the interplay between perspective and altitude. I think it's safe to say that claim number 2 is fiction. Claim number 3 is water surface. The claim about water's surface suggests that bodies of water, particularly oceans and lakes, appear flat on a small scale. This assertion challenges the conventional understanding of Earth's curvature. It's true that when standing near the shore of a lake or a small body of water, curvature of Earth isn't immediately apparent. This is due to the vast size of our planet and the relatively short distance over which we're observing. As we extend our observations to larger bodies of water, such as oceans, the curvature starts to become evident. Objects that are far away gradually disappear from view, bottom first, in line with the curve of Earth's surface. Our perception of the horizon can create the illusion of a flat water surface. Distant objects near the horizon appear to merge, giving the appearance of a flat line. This is the result of perspective and the limitations of human eyesight. The interaction of light, air, and water can lead to optical phenomena like mirages and bending of light. These effects can make distant objects appear distorted or displaced, contributing to misconceptions about water's surface and Earth's curvature. The scientific consensus maintains that Earth's curvature becomes more evident over long distances. The gradual disappearance of ships over the horizon and the way buildings come into view as you approach them align with the curve of Earth's surface. It's clear that the claim about water's surface hinges on scale and perspective. While bodies of water may appear flat on a small scale, they conform to the curvature of the Earth over greater distances. Claim number 4. Lack of photos of a curved Earth. Well, this claim suggests that there's a lack of authentic photos that depict Earth's curvature from space. This assertion challenges the established body of photographic evidence and raises questions about the nature of these images. In reality, there are numerous photographs taken from space that clearly depict Earth's curvature. Astronauts aboard spacecraft and satellites have captured these images, providing a wealth of visual evidence for spherical Earth. Some misconceptions about photos of Earth from space stem from misunderstandings about camera lenses and the nature of optics. Fisheye lenses, which can distort the appearance of curvature, have contributed to the skepticism surrounding these images. Astronauts who have orbited Earth and witnessed its curvature firsthand attest to the authenticity of these images. Their collective experiences and accounts further validate the photographs as accurate depictions of Earth's shape. Satellite imagery also contributes to the body of evidence. Over the years, satellites have captured countless images of Earth from various angles, all of which support the spherical model and showcase the planet's curvature. The scientific community asserts that the photos taken from space are consistent and accepted under the Earth's shape. The scientific community asserts that the photos taken from space are consistent with the accepted understanding of Earth's shape. The wealth of visual evidence aligns with other scientific observations and measurements. In conclusion, the claim about a lack of photos showing a curved Earth is not supported by the extensive collection of authentic images captured from space. These photos provide a visual testament to Earth's spherical nature. Last but not least, sunsets in perspective. It's their claim number 5. The claim suggests that the way the sun appears to set is not due to Earth's curvature, but rather a result of perspective. According to this perspective, the sun's gradual disappearance is attributed to its moving farther away, not Earth's rotation. Sunset phenomena like the sun's gradual descent and changes in color are well explained by the established understanding of Earth's curvature. As the sun moves lower in the sky, its light passes through more of the atmosphere, leading to scattering and color changes. Earth's rotation plays a significant role in sunset observations. As the Earth rotates, different parts of the planet move out of the sun's direct line of sight, causing the sun to disappear below the horizon. The perspective argument claims that the sun's apparent descent is due to its moving away from the observer, not Earth's curvature. However, this perspective overlooks the vastness of Earth's size and the consistent behavior of sunsets across different locations. The scientific response points to the fact that the sun sets earlier for observers at higher latitudes and later for those closer to the equator. This variation in sunset times aligns with Earth's curvature and rotation, not a perspective-based explanation. Visual effects such as the sun appearing larger near the horizon due to atmospheric refraction can contribute to the perspective argument. However, these effects don't negate the influence of Earth's curvature and rotation. The consistency of sunset observations across different locations and altitudes is a testament to the Earth's spherical shape and rotation. The perspective argument lacks a comprehensive explanation for the patterns we observe. It's evident that the claim about sunsets and perspective is not supported by the broader body of scientific evidence. The gradual descent of the sun, along with its change in color, is well explained by Earth's curvature and rotation. When we examine these claims through the lens of established scientific understanding, we find that they don't withstand rigorous scrutiny. Satellite imagery, gravitational measurements, and the way ships disappear over the horizon, and astronomical observations provide substantial evidence for a spherical Earth. It's essential to recognize that cognitive biases, like confirmation bias, can impact the way we interpret information. When flat earthers focus on evidence that supports their beliefs while ignoring or misinterpreting contradictory evidence, it reinforces their convictions. We see that the interplay between claims, evidence, and belief is complex. The scientific method encourages us to question, experiment, and examine evidence rigorously. In our quest for truth, let's remember the importance of critical thinking and open-mindedness. Let's take a moment and explore the fascinating factors that contribute to belief in conspiracy theories, like the flat Earth hypothesis. Cognitive biases are mental shortcuts that our brains use to process information quickly. Confirmation bias, for instance, leads us to seek out information that aligns with our existing beliefs, while ignoring contradictory evidence. Conspiracy theories can offer a sense of control and certainty in a complex world. They provide explanations for events that may seem random or overwhelming, offering a comforting narrative that makes sense to believers. Humans are wired to recognize patterns and make connections, even when one doesn't exist. This can lead to seeing hidden meaning or intention behind unrelated events, a tendency that conspiracy theories often exploit. Believing in a conspiracy theory can provide a sense of belonging to a community of like-minded individuals. Sharing a belief can foster social bonds and a shared sense of identity. Conspiracy theories often emerge in contexts where there is distrust of authority or institutions. People may turn to alternative explanations when they feel that the official narrative aren't honest or complete. Fear and uncertainty can drive people to seek explanations that alleviate their anxiety. Conspiracy theories can provide a target for blame or a sense of control over perceived threats. The rise of digital media has changed how we consume information. Echo chambers and algorithm-driven content can reinforce existing beliefs, making it challenging to encounter diverse viewpoints. Engaging with conspiracy believers requires empathy and understanding. Instead of dismissing or ridiculing their beliefs, open dialogue and presenting evidence can be more effective in shifting perspectives. Human psychology is a complex landscape that influences our beliefs and behaviors. Recognizing these factors can lead to more productive conversations and a deeper understanding of why people gravitate towards conspiracy theories. Our exploration of the flat Earth theory has taken us through its claims, scientific responses, and the psychology behind it. We've uncovered the intricacies of human perception, cognitive biases, and the social dynamics that shape our beliefs. The study of conspiracy theories reminds us of the importance of critical thinking and scientific literacy. The ability to assess evidence, question assumptions, and differentiate between credible information and unfounded claims is essential in navigating our complex world. The digital age has transformed how we consume information. Developing media literacy skills empowers us to evaluate sources, recognize bias, and distinguish between credible information and misinformation. Engaging with conspiracy believers requires empathy and effective communication. Instead of dismissing or arguing, fostering open dialogue can bridge divides and encourage a more nuanced understanding of different viewpoints. Conspiracy theories extend beyond the flat Earth hypothesis. They often emerge in times of uncertainty, distrust, and rapid change. Understanding their allure helps us address underlying societal challenges. Our journey has reaffirmed the importance of scientific exploration and critical inquiry. The scientific method encourages us to question, observe, and analyze evidence, leading to a deeper understanding of our world. As we conclude this episode, let's embrace the curiosity as a driving force. Curiosity leads us to explore, question, and seek understanding. By fostering curiosity, we can navigate a world filled with both mysteries and knowledge. Our journey through the flat Earth conspiracy theory has been a testament to the power of exploration, understanding, and dialogue. Remember, the pursuit of truth requires an open mind, a willingness to learn, and the courage to challenge our beliefs. Thank you for joining us on this captivating expedition through the world of conspiracy theories. Stay curious, stay informed, and stay connected. This is Gorka Myoxel with Conspiracy Chronicles. Remember to join us next week for another dive into more conspiracy theories.